Welcome everybody. Tonight we're going to be working on Unit 1, and this is basically our intro unit to computer programming. We're actually finally get our hands on doing some code. You can see the topic list that we have here, and given the fact that we just went through some Kahoots where we kind of reviewed these concepts, the one thing that I do want to kind of point out that the stuff that we're writing right now is going to be very low level and pretty simple, and you can take the programming prompt that I give you and very easily go right to the coding engine and start writing code. The analogy I gave during the Kahoot was, if you're building something a lot more complicated, you do want to start by building algorithms, either with pseudocode or flowcharts or both, right? So kind of like getting the blueprint for that house before you start buying lumber and nails and materials, right? So you know how much to buy and how to apply it. Another really important task that we need to worry about is file management. So like as we get into coding, I hammer this a lot heavier in some of my other classes, is I want to make sure that you guys have a place that you're storing your files. So I kindly ask that you read through this and come up with some sort of a strategy. If you happen to be a web student and you're taking like my web programming class, and I know there's a few of you here that are doing that, I want you to be mindful of the fact that file management skills are even more important for web people than they are for coders. Because in web, if you don't know where your files are, the websites don't work, period, right? With code files, you're storing them on your hard drive, whatever, you'll eventually find them, hopefully. But what I would encourage you to do is come up with some strategy that makes sense. One strategy that makes sense, and a lot of people do this, is they just bring up a file folder, right? That usually most people store their stuff in their documents folder. And then what I recommend is make a folder for Gateway. And then inside there, make a folder for your Python class. And then inside that folder, make a folder for each unit of homework. So like Unit 1, for example. And then all your code files for Unit 1 go in that folder. That way you know where to find them, right? Common sense kind of stuff. But in the modern age of computing, a lot of people have forgotten about file management, and it is really, really important to know where your files are. Another really good strategy is to use cloud storage. If you're using a Windows or a Macintosh machine and you throw stuff either on your desktop or your documents folder, those will automatically sync on a Windows machine to OneDrive. On a Macintosh, it'll sync to iCloud automatically. I choose on my personal machines not to do that, right? That's a personal choice. So I kind of circumvent what Windows 11 and 10 does, but most people are usually good doing that. The advantage of putting stuff out in the cloud, by the way, is if somebody steals your computer, all your files and your homework are still in the cloud. You can retrieve them. I'm also a big user of Google Drive, and one way you can get to Google Drive is through your email. So you can go to your email, click on the apps icon, and go to Google Drive. And if you want, you can create a folder structure inside here and just drag and drop your files into it right through a web browser. Another option for Google Drive is to use a product called Google Drive File Stream. And I'll just type it in. Right, just Google that, right? And basically what it does is it installs a piece of software that runs Google Drive Resident on your system. And then whenever you bring up a file folder, it creates a G drive that basically exactly mimics your file and folder structure in Google Drive. So I work with it locally, like it's a local folder, but in truth, it's out on Google Drive. I really like this. All of my academic work is done this way. I don't store anything on my own computer. It's all in the cloud. It looks like it's on my computer, but it's not. I really like this approach. And you do have this available through your student email account. So just be mindful of that. That's about all I'm going to do on file management here, but it's on you to know where your files are located. Being organized really helps, right? Otherwise, you save a file, you don't know where it goes, and it's like, well, I can't find it. That's not really good for turning in homework, is it? Yeah, it's not. Right. So make sure you complete that activity. File management is pretty important. I also kindly ask that you do a couple of little things in advance of coming to class. And I said this during the Kahoots and everything, that I have a lecture video that I've already recorded, and it's in 2 parts here. And given that the lecture is pre-recorded and this is going to be the fashion that we do this one happens to be from last fall, but it's a nicely done video, I think. It talks about computer history, the process of computer programming, the background of Python, it talks about algorithms and pseudocode, and also how to work and install Anaconda and Python, which we've kind of already done. But I think this material is really helpful. And in lieu of the fact that we don't have a textbook, this is how you will get some of your materials, is by watching those videos. Sometimes I will give you old videos to watch. Sometimes I'll record fresh ones if it doesn't quite match my content and my alterations, and be mindful of that. Any new videos I create, including the one I'm recording right now, will appear in the new section of the videos, right? And that'll typically be posted by tomorrow. I do publish everything on YouTube. I suggest you subscribe to the channel, but you don't have to, right? That's on you. All right. Beyond that, we are going to start talking about how to work with Python and working with our IDE. And what I do want to show you here is that I've shared a list of resources here in the form of links. So all the blue text here is links to information. I include the chapter 1 PowerPoint that matches these lecture videos, like where the material came from. If you care, you don't have to absorb that. It is optional. But the links that I provide here are kind of going to be in lieu of our textbook or reading a textbook. So when you see these in a unit and you see the materials, my expectation is that you read those materials. What I will also try to do, and I'm using the AI companion here, is that it'll kind of create lecture notes for us. So whatever I do in this video is going to be summarized in the form of lecture notes, which I will also embed into the course shell. And sometimes I will also add additional materials that are just informational that I will embed right into the content here. I forget if I did that here or not. No, I did not. But I will be doing that in future units, especially when the material gets a little bit more complex. All right, before I dig into these links here to talk about how to use Python, let's do a 5-minute break because we've been going for an hour already, whether you realize it or not. So I'm going to pause the video for a moment, mute myself, and we'll come back at, let's say, 8:51 and resume. So I will see you guys in 5 minutes. All right, we're back from break, and I am now going to go through the readings that I've posted here, which is a series of links on the W3 Schools website. I do have the links open in my Brave browser, and I do that basically to try to suppress most of the ads and active content that gets pushed in here on this free website. Just kind of a really quick reiteration, W3 Schools is this website that's built around the World Wide Web Consortium's 3 primary web languages of HTML, CSS, and JavaScript. And Python these days has become a really prominent backend coding language for the web. And they have an excellent section on Python. I'm on the Python homepage right now at W3 Schools, and I will drop that link in the chat. Of course, you can get to it through the course shell as well. We're going to go through some of these first few tabs here and then talk about the print function and then try to code some stuff. But this site is great, folks, as a reference. Like if you forget like the syntax for something, you can just come in here and go, how do you do tuples? Oh, that's how you do tuples. And you can just look at the example. And they have built in, which you'll see, for example, I just go to lists. They have these little try it yourself editors where it brings up a little coding environment on screen and you can tinker with the code and see how it works. Right? Phenomenal reference. It really is. And it doesn't just stop at like really simple reference materials. They get into file handling, some of the more common libraries, and AI people maybe have played with some of these already. Plotting libraries, and they get into machine learning, et cetera, et cetera, et cetera, et cetera. And I'm scrolling and there's just more and more reference materials. It's just an amazing reference. It really is, right? And that's why we opted to use it as kind of our primary source material for this course. All right, I'm going to go back up to the top of this list, though, and we're going to click on the intro, and we're going to talk about Python, and then look at a couple basic syntax features, and then we're digging into the exercises. So this is not going to be a super long-winded lecture. That's not my intent here. My intent for you guys, and I want you to remember this, is before you come to class each week that you should be reading through these links and trying the examples. I will talk about them very, very briefly. And in many cases, I will pre-record the materials and release them to you for consumption before you get to class. That's my intent. So let's take a look at this first little section here. It's like, what's Python? Very popular programming language. Some of the things we use it for: web, software development, math, system scripting. And I think, honestly, more importantly, data science and data analytics and artificial intelligence development. Those are probably some of the bigger uses of it. AI would not be around without Python, at least not the way we have it. Python has amazing free AI libraries that you can incorporate. You just have to know how to do it. Right? But you got to learn the basics first. What can Python do? It can be used on a server to make web apps, create software, can connect to databases, can handle big data and do a lot of complex math. It can be used for rapid prototyping or production-ready software development. So it can kind of do everything other languages can do. What is really notable, and I'm saying this to people who are experienced coders, like if you've ever coded, for example, in Java or C# or C++ or C, like one of those kind of common traditional languages, those languages are what we call compiled languages. We write code, it gets debugged, and it's turned into an executable file that is either an app or an exe file on your system that you can run. Right? You can't look at the source code. It just runs, right, after it's compiled. Python is an interpreted language, meaning it just reads the instructions and executes them. It's kind of like JavaScript. And actually, it makes it maybe a little less efficient than traditional programming languages, but it's also super easy to learn and you can run it just about anywhere. And that's why it's so popular. And it can do really pretty advanced stuff, honestly. It works on just about any platform you can think of. So Windows, Mac, Linux, whatever. You can run it on just so many different devices. It's kind of crazy. It's got very easy syntax to learn. In fact, what I tell my students is when they're first learning, it's like, if you're not sure, guess at the syntax. You might guess right. And sometimes Python is kind of forgiving and kind of works with your mistakes, which is kind of weird. It says it allows you to develop programs with fewer lines of code than other programming languages. Totally true. It runs on an interpreter system. It's not compiled, right? So you don't need like fancy platforms to run it. And it's still a procedural language and object oriented. So it really has everything that modern languages have, which is pretty awesome. We're currently using Python version 3. I do want to note that the previous versions of Python, so if you went to Python version 2 or older, those versions had not extremely different syntax, but fairly different syntax. When version 3 came out, which is what we're teaching here, the syntax changed and the language is still evolving. If you're using Python libraries, they do have subnumbers. I would say at a minimum, you want Python version 3.9 to do all the features we do in this class. Right? Not that you couldn't do it with older ones, but there's a couple features that don't work prior to that 3.9 version. I think the current version you get with Anaconda is either 3.12 or 3.13, somewhere around there, right? And it's not a bad idea to have the latest versions. I don't always say that for production environments, but for learning environments, I think it's pretty appropriate. Compared to other languages here, it's designed for readability. It's designed basically so that like one line of code is one statement. You're going to discover there's no terminating commands, like no curly brackets, no semicolons. So like if you know like Java or C languages, right, you get bombarded with that. There's like, oh, I forgot the curly bracket, or I forgot my semicolon. No wonder it doesn't work. Python, you just write the statement and then move to the next line and write another statement. And here they have a very simple little program which demonstrates the print command. And just to show you how the try it yourself tool works, I'm just going to launch it. So I can come over here in the left side. This is the code window. And I can, instead of saying hello world, I can say hello Milwaukee. because that's where I'm sitting, right? And I can hit the run button and it executes the code right here in your browser. Nothing to install, right? It just works. I wouldn't like develop programs in here, but real frankly, if you're trying to like refresh, like how does this work? Or let me try it here before I try it in my program. This is kind of a cool tool. And there's nothing to install, right? So pretty neat. I think W3 Schools does a really cool job of that. They also have a little video introduction here. I would ask you to watch this on your own, right? I don't want to waste class time playing the video that you can just watch. But it is a cool video. It's not that long, you know, so go ahead and please watch that. I'm going to move now to the getting started section, and this talks about what you have to do to get basically ready to code, right? So, and the first statement is true. You might have a machine where you already have software installed that required the Python libraries in order to operate. It's not uncommon. So maybe you installed a video game or some weird piece of software, or heck, maybe your computer came with the Python libraries already sitting on it, and you don't have to install the libraries. One thing you can do, and what they're demonstrating here, is you can go to a command prompt, type Python space dash dash version, and it will tell you what version you have installed. I'll demonstrate. This is not necessary, by the way, that you do this, but it is kind of interesting just to kind of watch it happen. So I'm typing Python space dash dash version, and I press enter, and it says it's not found. Right. I assure you it's on my system. What it's not finding is I don't have it as part of my path statement. And honestly, I'm kind of thinking that if I did Python -v, okay, that's not it either. But if you have it included in your path statement, that would give you a response. Another way to check to see if it's installed is to actually go into your folders and find the Python libraries. I don't recommend that because you're not going to find them. Most people won't. But it is important to have those libraries installed. If you installed Anaconda successfully, it installs the library for you. Otherwise, most major IDEs that use Python will either prompt you to install the libraries or also automatically install them. You can manually install the Python libraries. So how you do that is you go to python.org. This is a pretty useful site too, by the way. And you just simply go to downloads and download the latest version. You can see 3.13.7 is the latest version. If you've already got the stuff installed, you do not need to do this, right? But some people, nerdy types typically, right, will sometimes install libraries first and then install an IDE of their choice. For example, Visual Studio Code or PyCharm, something like that. Just be mindful that this site does exist and you can access it. They have some really simple examples of how to do this. We already did that. So we're going to move on now to the syntax section. When we start doing Python code, and I don't want you once again to execute these commands, you will notice that Python, because it is what we call an interpreted language, I can actually run it from the command line, from a command prompt, right? And type in a Python command and it executes right on the screen. It's really pretty weird. JavaScript is capable of doing the same thing. We can perform these actions inside our coding tools, which I will demonstrate once I get inside there. When you do write Python code, most of the code that you write, you don't indent. But if you write a statement that has a, let's call it a subsection of the code, you will find yourself indenting, and Python requires that your indents are consistent. Because the language does not use semicolons and curly brackets, indenting is the way that we show that a block of code exists inside of a structure. The real important part of this, frankly, is that the indenting is consistent. You can't indent 2 spaces on one line and 3 spaces on the next. Whatever your indent is, it has to be consistent. Otherwise, it doesn't see the code. And that's a common problem when you get started. All right, we did talk also about comments, remember from the Kahoot? And this is an example of a comment. So if I put a # at the beginning of some text, it will functionally ignore this information, right? And I'm going to bring up the try it editor just to show you. So, right, and just to show you that it's actually doing something, I'll change the text and then you'll see the output. But if I took this same print command and I pasted it in again, copied it and pasted it, but put a pound sign in front of it, this code will not execute. The other thing that will happen is if I put a pound sign at the end of a line and type some nonsense, that also will not execute. Why do we use comments? We use comments so that we can add extra information to our code, maybe just for ourselves, or maybe the next person that looks at it that needs to, maybe alter your code, you can provide a little piece of information for them or whatever. Comments are not obligatory, but you will notice that well put together code is often well commented as well. And there are some conventions for commenting, which I will show you as we kind of move forward. All right. So that's kind of the general approach, right? So comment and a comment. And basically you take a regular command and put that thing in front of it, and it's just not going to execute. The last little thing that we're going to lecture on here is basically the print function itself. Now, we've already been playing with it a little bit. And basically what happens is I use the print command with a set of parentheses, and then whatever I put inside those parentheses will end up on the screen that the user can see. When we start out, we're going to start out with what we call console programming, meaning we're coding for the command line. And folks, just about everything we do in this class is going to be coding for the command line. You don't get to the GUI stuff until you get to the advanced class, by the way, because we have to learn all the programming concepts first, and then we'll throw graphical programming in that advanced class, along with other stuff like database interfaces, backend for web, and stuff like that. The print command is a pretty easy one to use, and so I think it's time to try it. All right, so I'm gonna launch my Spyder IDE. There's two ways to do this, by the way. The one way would be to launch the Anaconda Navigator. So you can go to your start menu, start typing Anaconda, launch that product, find the Spyder IDE inside the interface, and click launch. And that's a fine way to do it. I usually like to skip the Navigator because I feel like it slows down my system. So I just go right to the start menu and type Spyder. It is Spyder with a Y, not an I. And then launch the app from here. And I'm going to let this load. All right. And this takes a little bit to load because it's a pretty big and powerful product. And most IDEs fall into this category. They are a little bit more robust than most simple pieces of software. All right. So be patient with it. You'll notice that even on my, I'll say relatively fast system, it takes a little while to load up. Right, so here it comes, and it's finally loading up on the screen. I'm trying to hide this panel here. Let's just close that panel. So most of it, when you land inside of Spyder, you will land inside this environment and will kind of look like this. You might get a little welcome screen asking you to take a tour. That's on you. If you want to do the tour, right? Otherwise, you can dismiss it and move forward. This product is a full-blown IDE. And remember, IDE stands for Integrated Development Environment. It provides, and I know I talked about this last week very briefly, and I'm just hammering it so you guys remember it. The coding window, which is the big window on the left, this is where we type our code and save our files in this window. In the bottom right corner is our console. When we run a program, the console will show the output. And then we have this kind of utility space up here that allows you to look at graphics or files or what values are stored in your variables, and also provides you access to the help menus. I usually minimize this one for early sessions, by the way, and I kind of arrange my screen like this. So I have the coding window is big and the console window is big. You can also zoom in. So if you do the trick where you hold down the control key and scroll, that works. Or you can do control plus and minus, that's plus, that's minus, to shrink the size of the text. Now, because I'm recording my screen, I make it big so you guys can see it well. I normally wouldn't do that if I was coding on my own. I usually want to get as much on the screen as I can at once. In the console window, and notice I clicked in here and the blue outline formed. This window is now active, and I can do Control Plus here to make that bigger if that helps you, right? You might not need to do that. Because Python is an interpreted language, I can actually type Python commands directly into the console. This is kind of cool. So I can type print and then say hi or whatever, right? And then I can press enter and it just does it. Notice it gave me the output here. Also, because it's an interpreted language, I can do like really goofy things like 4 + 4 and press enter and it does the math. Notice I didn't even use a print command. So Python is capable, because it was written as a scripting language for server automation, capable of executing commands directly in the console without writing code in the code window. And sometimes you just do this to test things, right? I don't do it very often, but it is capable of doing that. JavaScript also has this capability. The reason is because it's interpreted and not compiled. Over in the coding window, we can start to write code. And I just want you to notice here that there are line numbers, right? And line numbers are helpful, by the way, especially when you get error messages and it says, go to line 8, column 5, and find your error, And if if you're not seeing line numbers, if your IDE doesn't have that, you are really going to be struggling, basically. All right. You'll notice as there is an untitled file in here, this is automatically created by the IDE. And notice the top line, and these lines are not necessary, by the way, you can delete them. There's a little comment here indicating what character set we're using. Irrelevant, you can delete that. I don't usually do it, but I'm just showing you that it doesn't matter. And then here's one of the alternate ways to do comments, which is 3 double quotes, type whatever you want in a block, and then close it with 3 double quotes. If you want, I don't oblige you to do this. You could put, for example, your name up here, maybe the name of the assignment. And then what I sometimes use it for is to provide extra information. Like sometimes if I have a programming prompt, instead of looking at it in a document, I just copy it and paste it in here, and then I have it up here. Right. So once again, not obligatory that you use this area, but it's there if you want to. Right. I'm going to now go back to the unit folder, and I'm going to get poised to code through our exercises. And at the end of it, I will show you how to submit your exercises. The first thing I do want to do is kind of walk through the anatomy of how this works. I am using exercises that came with our previous textbook. And what I've done is I've captured them in a document, which is attached to this thing. Now, I don't see it here without clicking on the title. So I'm going to go ahead and click on the title of the assignment, and then you will find that document down here. So I'm going to open this up. Download it and open it, and I'll bring it up on the screen. And then my goal is to find all of the exercises I have listed here in this document and then write the code for it in the IDE. So the first one we have to do is exercise 1.1. I do want you to notice that every exercise will kind of be in this format. I'll tell you which exercises to complete, and then make sure that you do these tasks. So create a folder for your exercises, save each program as a separate file name. And I know some of you in the first unit will try to do them all in one file, whatever, I don't care. But if you do that, make sure you let me know about it, because my expectation is that you create separate programs. Part of it is to practice, right? Follow the directions for each exercise and create the program as described. I will demonstrate. Make sure it works correctly, fix any errors. Right? As you complete each program, do screenshots, put those into a document, and then when you're all done, you'll zip your code files and submit those, and you'll submit the screenshot document, both. I will demonstrate that process, but right now let's focus on the code, okay? So the first exercise is exercise 1.1. It is a pretty simplistic programming prompt, and what I'm going to do here is I'm just going to copy this, and I'm going to go back over to Spyder, and I'm going to paste it up here in the comment area, and it looks like I grabbed the number 1 with it, so I'm going to delete it. Right, so this says, write a program that prints a greeting of your choice, perhaps in a language other than English. So if you want to speak Spanish or Greek or German or something, you want to do it in that language, that's fine. So this is a really basic program. So let's do the print command, basically. So follow along, type print, a set of parentheses, inside the parentheses, a set of double quotes. Are you noticing as you type, I type one parentheses and it adds the second one. I add one double quote and it adds the second one automatically. Now, in between those double quotes, I can put in whatever text I want to appear on the screen. So I'm going to say, greetings, Earthlings. We come to destroy your planet, or whatever, maybe something a little friendlier than that. All right. Once you have that typed in, this is the first exercise, folks. It's a very simple one, obviously. You can hit the little button up here and notice as I hover over it that the alternate for pressing this button with your mouse is the F5 key. F5 will trigger it. Now, for a lot of people, that doesn't work anymore because our F5 keys might trigger your camera or something. So I suggest clicking it instead of doing that. So you hit the play button, and then over here you see the output, right? And it looks like it worked. Notice that the output window will indicate what file we're running as you're running it, and the location in my file system. Right now, it's not saved, so it's kind of somewhere generic. That's not good, by the way. So it did work, though. So now it is currently unsaved, and I want you to notice, like right where the tip of my mouse is pointing here, there's a little asterisk on this tab, meaning this file is not saved. So I'm going to go ahead and do a save as. Now, normally, and I say this, and I'll do this as I go forward, whenever I create a new program file, what I like to do first is save it. So get this as a procedure. New file, save as, right? That's like your first step before you do anything else, because otherwise you forget to name it, and this is how files end up in goofy spots. So the first thing I'm going to do is I'm going to choose a name for this. Now this is exercise 1.1, but I don't want to really put a dot in here, so I'm going to do _1. And this is just what I'm going to call it. You don't have to call it this, but whatever you call it, make sure that you can find it later. My thinking is if I want to find exercise 1.1 later, I'll name it EX1_1, because then I'll know what it is. See my thinking? Right? Where am I going to put it? I'm going to put it in a folder that makes sense to me, right? That might be different for you. So for me, it will be my Google Drive. I will go to my Python class folder, and then I will create a folder for this semester, which is fall 2025. And then inside that folder, I'll make another folder, and I'll call it Unit 1. And then all my Unit 1 code files will go inside here, and I will click Save. I want you to notice after it's saved that there is a .py appended to it. That's the correct naming format for the Python file. So now this is saved. The other part of completing the exercise is capturing those screenshots. Okay, so I'm going to create a new Word document. So I'm just come in here, create a new document. If you don't have Microsoft Word installed, your alternative to this would be to get into your Google account, like your Gmail account, basically, and you can go to Google Docs off of the apps icon and create a new document here. If you create it in Google Docs, I want you to be really mindful that when you're done creating the document, that you want to go to the File menu and download it as a Word document. That's the format I want. Okay, the reason why is that renders inside a bright space beautifully, and I can see it. So predominantly when I grade your work, I'm looking at the Word documents and your screenshots to grade. And if I think something looks fishy or wrong or it has errors, then I will open up your code files and try to run them. But sometimes I can just grade it just by looking at the screenshots and be done with it, right? It's a whole lot faster. The other mechanism here is the fact that in a document, I can like put in stuff like I can put in names. I can say exercise 1.1. And then I can start dropping in my screenshots. And yeah, you can make the typography better. You can do, change your fonts or make them bigger, smaller, whatever. But the bottom line is I just want it to be readable. So here's an example of doing a screenshot. If we are inside of Windows, Windows has a screenshot tool called the snipping tool. If you're on a Mac platform, it's called Screenshot. On a newer Mac, if you have an older Mac, it's called Grab. Linux platforms also have this tool, but you'll have to research for your distro if you happen to be one of those geeks. So on Windows, I'm going to go to the Start menu, and I'm going to start typing snipping tool. I just typed SNI, and it just came right up. I'm going to launch that program. It brings up this tiny little interface, and then I'm going to capture my code. Now, please, don't capture your whole screen. Don't give me a whole screenshot, especially if you have a monster-sized monitor. I want you to zoom in on just the code that we need to look at and the output we need to look at. And I would prefer that they're two separate screenshots. So for example, I'll say new here, and I'll grab my code. I'm grabbing the line numbers too and my little prompt and everything. And there it's captured. I don't need to save this as a file, by the way. All I need to do is click the copy button, or you can do Control-C, and then I'll go back to my document, whichever one I'm working on, and I'll just paste the image into the document. I do want you to notice that the size of the font in the screen capture is roughly the size of the font in the document, which makes it readable. If this is a lot smaller than that, I might not be able to read it, right? So just be mindful, right? I'm also going to capture the output. So I'll go to Spyder, bring up the snipping tool again, click New, right? Screen grays out, turns to a crosshair, click, drag, select, and there's my output. I'll copy that, and then also paste that into the document. Ideally, I would also like to get a little feedback. Like if you struggled with something a lot, or it just didn't work, or whatever, type something up and say, you know, this was a nightmare, or whatever. Or maybe something like, worked fine, you know, no issues, whatever, you know, and full sentences, please. So when I go to grade, I'll open up this document, I'll look at the code. If there's errors in the code, and I'll show you this pretty soon, it'll highlight red. So I'll know there's problems just by looking at the screenshot, you know, feel where I'm going with this. But most of the times, these early exercises, especially, I don't usually run the code. I just look at the screenshots and move on. Stuff's pretty easy generally. So let's move on to the next exercise. I'm not going to screenshot anymore, but for all the subsequent exercises, you should be doing that. You don't have to do it right when you do the exercise. You can do it afterwards as well. That's fine. All right, let's go ahead and move on to the next exercise prompt here. The exercise that we need to complete, and I guess I should probably look at which one I need to do. Next one is exercise 1.2. So I'm going back to that document, and I see exercise 1.2 here. And I'm going to copy this prompt, and then I will attempt to explain it to you in a way that makes sense. I'm going to come up to my toolbar here. I can either choose the new button to create a new file, or I can go to the file menu and create a new file. And notice it creates a new untitled tab. First thing you do is what? Save your file. So I'm going to go to Save As right off the bat, or you can click the Save icon. And this is exercise 1.2, if I remember right. So I'm going to name it in the way that makes sense to me. So I do X1_2. That's how I would do it. Then I'm going to go ahead and click Save. And that way I don't forget it and I don't lose where it goes. See my logic on that? But I recommend that procedure, honestly. Like in any piece of software that you use where you're saving a file, you should open it, and then first thing you do is save it. Rather than take the risk of your operating system doing it for you and putting it God knows where, naming it God knows what. Right? That's not a good scenario. You need to be in control of those things. I am going to zoom in here. I do have the programming prompt copied, so I'm just going to paste it in here. Once again, I got the number, so apparently, let's continue a little problem there. It says, write a program that prints the sum of the first 10 positive integers. Okay. So in other words, just saying 1 + 2 + 3 + 4 + 5 + 6 + 7 + 8 + 9 + 10, and give me the output. Okay, here's a handy little rule of thumb whenever you're doing math in a computer program. Like you're writing a piece of code that's going to do math. Don't count on the fact that your code is correct and giving you the correct answer. So mind those words real carefully. Whenever you do math inside of a program, you need to have a way to validate that the math is correct. One tool is a calculator. So I could just go, for example, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 55. So I know the correct answer before I even run the code. Another tool you can use, and I'm not going to do that in this session, but future sessions I will, is sometimes I use an Excel spreadsheet when the formulas are more complicated. So I test the formulas in Excel to know what the answers are, and then I bring them into my coding engine. Right. So these are just little tips and tricks, by the way. Always validate your math. So let's write the print statement. It should be really simple, right? Now this time we will omit the quotes, because if I put quotes in, it'll just put whatever I type back on the screen, not what we want. Right. So what I'm going to do instead is I'm just going to type what I typed inside the engine: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay. Now, notice, like, if my code's broken, like I took away the closing parenthesis, what the IDE did, it threw up a little red symbol. That what this tells you, if you see a red symbol, your code's probably not going to run, by the way. Right? And it's the error message is kind of weird. It says unexpected end of file while parsing. So meaning it doesn't tell you that you're missing a parenthesis. So the error messages aren't necessarily clear, but it does indicate where the problem is so you can look. Right. So let's go ahead and run this command. Control S to save it, and then hit run. Right. And then you can see we got the same answer here that we got with the calculator. So I know my code worked correctly. Right. Once again, screenshot the code, screenshot the output, and move on to the next exercise. So I am now going to move on to the next exercise, which is exercise 1.6. Exercise 1.6 is kind of one of these goofy ASCII art things. And I don't know how many of you know what ASCII art is, but that's basically where we use like plain text characters to create pseudo graphics, right? And this is really more an exercise about learning how the print command works, and that whatever you put inside those double quotes will be preserved in the output. So let me give you an example. The prompt is basically write a program that prints your name in large letters, right? And you see like Harry used asterisks here, and had to kind of figure out how to make those asterisks form his name in combination with spaces. So I'm going to come over here to Spyder, and I'm going to build this program. So here's a new file. I'm going to do a save as, right? First task, save as. This is exercise 1_6. Zooming in. And I'm going to do a print command. And I'm going to do, okay, this is weird. I'm going to do a blank one. Okay, why am I doing a blank one? If I do a blank print command, it'll work. This just worked. What did it print? Nothing. Perfect. That's what I wanted. No, okay, why am I doing that? Because I don't know if you guys are noticing when you get these run commands, the output sometimes starts right after this stuff, and it's kind of hard to look at. Where if I do a print command and then I have a blank line above it and I run it, then it just creates a little visual space here that makes it easier to look at. For me, that's my advice. Web developers, I always tell web developers it's easier to look at content on the screen if it's got space around it. If it's jammed up with stuff, it's complicated. It's hard to look at. So that's not actually what I want to do here. What I'm trying to figure out, okay, so Harry kind of put his name together And I'm assuming that this whole line here of asterisks is probably one print command, right? And notice that it's probably an asterisk, a space, 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 asterisk, space, 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 you know, so that's the mechanics of what we're trying to work up. But what I'm noticing is he did his name over the course of 1, 2, 3, 4, 5 lines of text. So here's what I'm going to do is I'm going to take one of these print commands and one with double quotes inside of it that's already pre-created, and I'm just going to highlight it, copy it, Control C to copy, or right click copy, and then I'm just going to paste it. So I have 5 lines. Right? Is that what I did last time? Yeah, 5 lines. And then I got to figure out how to like do my name. Now, I feel sorry for you if your name is super long, right? You know, if you have like 20 letters in your name. I'm going to go with the nickname version of my name, which is Ty, just TY. And I'm going to figure out how I can put a T together using ASCII art. So what I'm going to do is I'm going to type an asterisk. You could use other characters too, by the way. And I'm looking at what I did last time, which is I did 7 asterisks across the top. All right. And I'm just going to try to make the T first. And then notice what I'm going to do here is I'm going to move my cursor over, basically inserting spaces, and try to get that asterisk kind of in the middle of that T structure. But we got 1, 2, 3, 4, 5, 6, 7, 8. Well, I got an even number. That's not good. So let's get rid of one of those up here. So now I have 7. So I'm going to backspace this one. So the T, the bar of the T that goes up and down is going to be in the middle. And you know what? That's going to repeat for the rest of the T. So I could actually take the stuff inside here and just paste it, right? I'm trying to be clever and save time on it. So that kind of looks like a T. And you know what? I could test it already, even though I'm not done. And I'm like, yeah, that looks good, right? Now I just got to get the other letters in there. And this is a little bit of a trial and error process, and that it's okay to be fumbling on this, folks. The point of it is to fumble a little bit to get the feel of it, of like how the engine works. So to do the Y, I'm looking at how I did it last time. I did an asterisk, and I'm going to have to like probably do like a few spaces in there. And then on the next line, the Y comes in on an angle, so I can't put my asterisk here. It's probably got to go over a little bit, and then a couple spaces, and then this one's got to be, yeah, it looks pretty good, right? But you see where I'm going with this, right? And I'm going to just keep adding, and I did a tab there, which is not a good thing. I'm going to use just spaces. Nope. I want to put it here. And here's what I'm noticing. How am I going to now put one single thing below it, not have it be off kilter? So I think what I have to do is I have to add a space on each one of these. And this is the kind of finagling you're going to do to make this work on your own. And maybe this isn't really a good example because I think of the Y that I made last time. I'm looking at a solution on my other screen was a little nicer. So I have a way to fix it though, right? That looks more like a V than a Y. I don't know if you guys agree. So what I might do is I might add another print line to just make the Y a little bit taller. And then I'm going to hit run. I want you to notice a really interesting feature here too. When I hit the run button, right now my file is not saved. I see that little asterisk here, but the moment I hit run, it automatically saves it for you. And that doesn't look too bad. You might have to finagle this a little bit to make it look cool. Believe it or not, there's a whole school of artists that create artwork using characters like this. They call it ASCII art. The reason that we're learning how to do this is really more to learn about the print statement and the fact that the spaces that we put in here matter, right, in the output, in the print statement. The other thing that's kind of interesting is that the way the characters sit inside of here is completely controllable by you, right? Granted, we're not outputting to like a Windows program right now, we're outputting to the console. But you know, in the old days when computing was nothing but console, this would have been a thing, right? To be able to even do this. But it's about learning the print command and the nuances of how it operates. So play with it. You might have to finagle it a little bit to get it to look kind of okay. It's actually kind of fun. So this is a simple little exercise. So that was exercise 1.6. The next exercise is exercise 1.9, which is a very similar exercise. Okay, so I'm going to go to the document, and for that one, they want us to make this little house. And notice this one's a little bit more complicated because it's not using one character. It's using a bunch of different characters and dots and dashes and this weird up down line, which is not the letter L, by the way. And this one is pretty easily coded too. So I'm just going to go ahead and do it. This goes pretty fast. I will say that if you guys feel like I'm going too fast right now, just remember, this is a recording that I'm making right now. Tomorrow you can look at this recording, pause it, slow it down, and copy everything I'm doing if I'm going too quick for you. Right? I just want to make sure that I do get through the coding exercises. I'll zoom in here. I will do a save right away. This is exercise 1.9. Hitting save. All right. As I did before, I'm going to have a bunch of different print statements to make this house. So why not just borrow some of the code that I had on the previous page, right? Like I have all these print statements. Okay, well, I probably should just borrow that one, right? But I could put it in there. And you know what? I will start with a blank line again. And then I'll paste it in again, but this time I'll add my double quotes. And then I'll highlight that whole line and copy it. I don't want to keep typing this. Be smart. Don't type a lot if you can copy paste, right? And so let's just do however many lines I think we need. And here I'm determining 1, 2, 3, 4, 5, 6, 7 lines. And in here I have 1, 2, 3, 4, 5, 6, 7. Okay. Now we start building the house. Now, here's where it gets kind of weird. If you try to figure out how many spaces precede that plus sign, right? It might be kind of hard to count them. You can actually extrapolate it here. What I'm going to do is I'm going to start with the bottom line first. That's the way my brain thinks, which is plus, minus, plus, minus, plus, minus, plus, right? So remember, plus, minus, plus, minus, plus, minus, plus. Then I'm going to look at the next line. It's the pipe. Now, pipe, and that's a character on your keyboard, by the way. For most keyboards, this will be right above your enter key. So right above the enter key, there's a backslash key. You have to hold on the shift key to get a pipe symbol. But this one is pipe space, pipe space, pipe space, pipe. Say that 5 times fast. Pipe space, pipe space, pipe space, pipe. I do want you to notice, and some people go crazy over this, by the way. They look at that pipe symbol and go, that's not straight up and down like it is in the book. Why is this on an angle, right? This is the coding font set does this. I assure you, if you run this code, it comes out straight up and down in the output. So don't freak out to the slight slant. Some people go as far as changing the font in the editor, and I think that's just a waste of time. Right, next line is pipe space dot dash dot space pipe. Right, all right, just to kind of accelerate things here, I'm going to copy paste it from my solution. So there it is, pipe space dot dash dot space pipe. The next line is a plus dash 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 plus. Then I go up to this one, and then I start getting the angle of the roof. So I'm going to go space plus space 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 plus. I think that's right. We'll find out in a couple of lines. If it's not, we'll fix it. Then we'll go space space plus plus space plus, and then up to the top line, right there. I'm going to go ahead and run this, and there you can see I got a little house. Yay! Very exciting stuff. Interestingly, right, like if you decide like here to add a bunch of spaces after, that's not going to do anything, right? I mean, it's still in the code, but wait, I mean, there's nothing there. That's why we end the line where we do. Okay. That was exercise 1.9. We're going to move along now. Next exercise is exercise 1.11. All right. This is another pretty basic little assignment, and it's really, once again, getting you comfortable with these commands. And the prompt here is write a program that prints 3 items. For example, 3 of your best friends or your favorite movies on 3 separate lines. Okay, so once again, I'm gonna kind of borrow some of the code I had before, and maybe this is still in my copy paste buffer. Let's first make a new program. What's the first thing we do? Save. This is exercise 1_11. Zooming in. And I'm just going to paste in the print command, right? So I have a print command already ready to go with double quotes because I copied it before. I just had to paste. Maybe you did the same thing. I don't know. And then I got to figure out, well, I'm gonna have 3 movies I want to list, right? So I'm gonna need at least 3 more commands. Right? So paste, 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 paste. All right, well, that's 4. Well, maybe I can have a title in there. So maybe the first one can just say something like favorite movies. Okay. And then I can start to list them. All right. So here we go. And I'm not sure if this is still accurate for me, but when I first typed it, it was, or I thought it was. Right, you guys can judge me all you want. And this is really not one of my favorite movies. Well, maybe it is one. Oh, so I'll okay, here we go. That's a good movie too. All right. You might want to pretty this up a little bit, and I would encourage you to do that. So if you want to like play with the formatting of ASCII text, I think it's kind of a fun process. So I'm going to add a few more lines in here and just kind of show you some of the goofy stuff that, and I'm just mimicking what I did last time. Notice, okay, I have blank lines here. I don't need double quotes. That doesn't harm it any, but I'm trying to make it look as nice as I can using what I have, right? And this is, pretty basic. I could see a couple of other, I mean, I might tweak it. Like if I was like really serious about it looking really cool, right? I would like sit there and tweak it. I think that looks a little better. And maybe, I don't know. I could think of a bunch of different things I could do to make that look better. But the whole thing is to organize the information on the screen and present it in a way that's meaningful to the user. Right. So 3 favorite movies, your best friends, favorite songs, whatever you want to do. Right. Play with the print command. Let's move on to the next one because time is waning quickly if you haven't noticed. And here's one that it's kind of basically the same exercise again, but this is kind of a fun one. Exercise 112 is to do what we just did, but this one will print a poem of your choice. And by the way, most people don't know any poetry or care about poetry anymore. So you can like search the internet for Emily Dickinson if you want. Or how about this as an option? Instead of doing a poem, aren't songs poems? So find the lyrics to one of your favorite songs. If you're not sure of the lyrics, you can do something like, right? And you could copy paste them and wrap print commands around them and output them to the screen. How about that? Now, I'm not going to do a full demo on this, but what I did last time, right? I'm just going to show you because here's my cheat code from the other screen. Is I just took, I didn't do the whole song, by the way, I just did a couple of verses of it. I wrapped print commands around it and I tried to make it look as nice as I could. Notice, She Loves You by the Beatles, and I put a little dash line, and then I put the words in, created a blank line between the stanzas, and put in the chorus, et cetera, et cetera. Right. Once again, practice with the print command. Right. So I don't feel like I need to demonstrate that one too much since we just kind of did a whole bunch of that. So be mindful of that. I have faith that you can complete that on your own. Let's look at the next exercise here, and I'm trying to find my unit folder, which I seem to have lost, which is right here. And the next exercise is exercise 114. 114 also practices this type of thing. And I do want you to notice here that as we get into these exercises, some of these are marked with different categories, and later on we'll have data science ones and graphics ones and things like that to play with. But at this point, they want you to write a program that prints a 2-column list of your friends' birthdays, right? In the first column, print the names of your best friends. In the second column, print their birthdays. Once again, I'm going to put this on screen really quickly to show you my code. Now, if you guys are, I'll just give you guys a clever little tip here. You're impatient, you don't want to wait for the video tomorrow. You could, like if you were clever, you can screenshot my Zoom window. Like I have students do that. Every once in a while, when we start writing more complicated code, I will start dropping like complicated code into the chat window and you can just copy it. But I'm just giving you an example of how to complete this one. This is what I did. So birthday list, I did a little ASCII art there. Then I put names in the first column, and then I made sure everything lined up, and then put the month and the date in separate columns. But you notice how I tried to line them up? All right, that's kind of the point. Practice with that to get the output to look nice. All right, last exercise of the exercise set is exercise 115. So back here to look at the description. And this one is going to involve, and I'm just giving you a heads up, this involves a little bit of research. All right, so it says in the US, there's no federal sales tax, at least not yet. You know, I can imagine someday that'll be coming, right? So every state may impose its own sales tax. And if you live here in Wisconsin, you also realize that every county or every city can impose their own sales tax. What is the sales tax rate in Wisconsin? Google it if you have to. All right, I'll do it for you. Now, whoever typed in 8, you're outing yourself as living in Milwaukee. And it's actually 7.9, by the way. But the sales tax in Wisconsin is actually only 5%. In the city of Milwaukee, they add a bunch of stuff, so it goes up to 7.9. Another really interesting tidbit most people don't know is if you go to an entertainment venue, a bar, a restaurant, a theater, a concert, those kind of places, the sales tax is even higher, right? So when you go to a restaurant, you're calculating your tip and your tax. And I think that like at a restaurant, it's like 10% tax at a restaurant in Milwaukee. Crazy. If you go to like Illinois, it's like, I think it's like 10% in the city of Chicago for sales tax. So you always have to add that on top of whatever you're spending. There are some states that have no sales tax, right? And Alaska is one of them. But basically what they're asking you to do is find the tax rate for the states, for 5 different states, and make a little table out of it. So you have to research that. Another little tip I will give you is whenever you look at programming code in a book and they do this, ... that means, and there's more stuff that should go here, but we're not typing it out. It's implied. That's what that means. So that means sales tax rate, they gave you a title, they gave you 2 states and their values, and you got to come up with the rest. So you can copy Alaska and Hawaii if you wish, right? But if you grab Pennsylvania, you're quickly going to find out that that's really long, and then the tax rate column needs to move over. So it's kind of like working out the mechanics of that is what you're really doing. All right, that's the assignment set for this unit. We finished it just in the nick of time, right? Some of this you do have to code on your own, but I think most of you are going to be okay. If by any chance you get stuck, just reach out to me. I'm glad to help you. The other thing I do want to point out before we adjourn here tonight is that in the unit folder, and I'm going to do this often, and not all of our units, but most of our units will have extra credit opportunities as well. So if you scroll down to the very bottom here, you're going to see I have 1 extra credit opportunity, which is to complete 2 additional exercises. If you get those to work successfully, and by the way, they're both pretty easy to do, you can earn 1/2 point of extra credit for each one. So my idea is like, why not do it? Get some extra credit points and you can bank them, and it gives you a little cushion when you get to tests and stuff, right? So Those exercises also exist in that document. So find those exercises in the document, read the instructions, and try to create it. Once again, if you get stuck and need help, just email me. I'm glad to do a one-on-one Zoom with you, or come to my office hours and I will help you fix this. Please make note of the due date. Today is September 15th. We've already coded all this stuff, right? The little bit that you have left, you have plenty of time to finish it and turn it in. Right? My thinking is, remember, next week's class is on the 22nd. This due date is 2 days after. That way you can come to class and ask the question if you're stuck, fix it, and still have 2 days to get it in on time. There's not really a lot of excuse for having late work in this class, especially when I do your homework for you. You guys feel where I'm going with that. Make sure that you do your screenshots. Make sure that you also zip your code. And that's the part I guess I didn't demonstrate yet. But when you're submitting your homework, you need to also zip your code. So I'm going to go find my code files. I'm already in the folder, I guess. And I'm looking for my Python 2025 folder, which I know I created, but where the heck is it? Oh, I named it Fall 2025 instead of year and month. You know what? I'm going to flip that. Maybe that's not a good idea while the IDE is running. But I'm basically going to go into this folder, find my unit folder. Here's all my exercise files. See, I just highlight them all. And then I can right click and compress to a zip file. Please do not use 7-zip, tar, or rar for your zips. Please just use zip, because Brightspace prefers that better. And you could name it like Unit 1 code, for example. And then when it's time to submit your homework, I'm going to go into student mode here so you can see it. Oops, wrong unit. You go to the assignment title, click the title, and down here at the bottom, I will upload my code file. So that is in my G drive, right? I'll show you how to get there again. There's my zip file. And then I also will have a screenshot document, which I'll also attach. And then I will view that. So if you want to, I guess I have a screenshot document here, even though it's basically, well, it's basically blank. Let's just say there's something in it and save it. So I can save that to, the same folder ideally. Right? And this is why it helps to know where your files are located, folks, because then when it comes to like finding things and doing stuff, you don't have to guess. You know exactly where the stuff is. So I'm going to save that inside that folder, and then I'm going to go ahead and upload. Hopefully it goes back to the same folder, and then I can add the document as well. And then on the receiving end, I will have your code file and your screenshot document. Truly, the screenshot document, at least in the initial parts of the class, is the important piece. But think of the zip file as kind of like a backup. If you don't do the screenshots, at least I have something to grade. I will complain about it a little bit because if I ask for a screenshot document, I want it. But it also creates a backup for you. So like if you lose your files or delete them accidentally, or somebody steals your laptop, if you zip all your code files, I have them as a backup for you. And I can extract them from Brightspace and give them back to you if you want them. I'm going to go back to our topic list here just to make sure that I covered all the topics. We talked about algorithms, file management, computers and programming, how to do Python programs, runtime, compile time, errors, how to use an IDE, how to submit the homework, covered all the lecture topics. We're good for the night, folks. Next week, for next week's class, and I guess I'll record this into the video too, we are moving into Unit 2, which takes us into a new topic. If you want to see what the topic is programming with numbers and strings, and that's a two-parter. I will post the lecture materials within a day or two, and so you guys can go in there in advance, watch the lecture videos, read the materials I share, And then if you're ambitious, you want to start coding, you can go for it. Otherwise, next week in class, we'll Kahoot on the topics, and then we'll code through the exercises. If not, now I'm hoping to see the feel and groove of the course now. And as we move forward, that'll become very comfortable, right? And as we get deeper into topics, I will get deeper into lecturing while I code and demonstrate all sorts of stuff. All right, folks, this video ends here, and this session is done for the night.